David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Okay, today's topic, reflections. Another kind of translation that we're going to do in this unit. First off, I want to review. Reflections happen across a mirror line. So if I draw my mirror line like this, and I take my point P to get the reflection, I just reflect it across the mirror to my P prime. Now, you'll notice something here that I've marked on my diagram. The mirror line bisects the segment connecting the original and the image point. And in fact, it bisects it perpendicularly. So the mirror line is a perpendicular bisector of the segment connecting the 2 points. Okay, so in this unit, we use only 4 reflection lines. In truth, you can reflect across any line, and you may be exploring that later in another class. Here, we're going to reflect across the x-axis, that's abbreviated m sub x, across the y-axis, m sub y, now across the x equals y line, abbreviated m sum x equals y, and then the other one is m sub y equals negative x. That's across the line, y equals negative x. So what I've done is I've sketched a graph here. I've put my x and my y axis, let's give them labels, and then I've also sketched in my x equals y line and my y equals negative x line. So those are the 4 lines that we reflect. Now what I've asked for, find the image of the point 3, 1 for moving it across the mx, the my, the mx equals y, and the my equals negative x. So if you want to pause the video right now and see if you can reflect that point, put it in its new spots. We've got 4 reflections to do. See if you can figure out what the coordinates are. Okay, let's do the simplest one first. Let's reflect it across mx. It's 3 over and 1 up. So to reflect it down, we're just going to go 3 over and 1 down. So this is going to be 3 minus 1. Okay, that's our first reflection. Second one, also the easier one, is to reflect it across the y-axis. I'm 1 up, 3 this way, so now I'm going to go 1, 2, 3 that way, but still be 1 up. So this is going to be negative 3, 1. So that's reflecting across the y-axis. Now these two, the diagonal lines are going to be a little bit more difficult, but not by too much. So this one is 3 over and 1 up. To get the reflection, I'm going to go 3 up and 1 over. And so this is going to be 1, 3. And you can see I've drawn that pretty much to scale. It works. Now this one is the most complicated one. We're over 3, 1 up. So now we're going to go down 3 and 1 over. And this is going to be negative 1, negative 3. Okay? So those are the 4 reflections, and you can kind of see they do reflect across their lines. Like that, and then finally like that. Okay? Okay, so now that we've played around with the point 3, 1 and reflected it, first across the x-axis, then across the y-axis, then across the line y equals x, finally across the line action. Okay, so now that we've reflected the point 3, 1 across the x-axis, the y-axis, the line x equals y, and the line y equals negative x, and we've figured out what those reflected point coordinates are, we're going to make some general statements about how these reflections work. So we're going to fill out this table here. Okay? So a little bit of notation. The point xy reflected across the mirror line x, that's the x-axis, that's what the arrow there stands for. What we noticed is that the x is the same value, right? We're reflecting across the x-axis. So 3 stayed 3. We stayed 3 to the right of the origin. However, the y-coordinate got reflected, and so it went from 1 to negative 1. So we know that it's going to map it to the same x, but now it's going to be the minus of that y. So what that gives us are transformation equations like so. X prime, the reflected point, is the same as the original point. However, y prime is the negative of the original point of y. Okay? So what I'd like you to do is pause the video and see if you can fill out these 3 spots and then write the transformation equations in there. So give that a shot. Think hard, look at your diagram, see if you can get that. Okay, so let's take a look. Reflecting across the y-axis, we went all the way across, and our x went negative, and our y stayed the same. So this is going to be negative x comma y. So kind of like this one, but we just changed the x instead of the y. So now x prime, the reflected coordinate, or the x coordinate of the point, is going to be negative x. Now y prime is going to stay the same as y. Okay? So fairly similar, just the action happened on the y coordinate instead of the x coordinate. Now these two are a little bit more complicated. Let's take a look. Reflecting across the line, x equals y. So that was going across that way. Now notice the values just switched. Right? Our x-coordinate switched from 3 to 1, and our y-coordinate switched from 1 to 3. So what we get here is we get y comma x. So now what happens is x prime equals y, and y prime equals x. So we just switched the coordinates. Now this last one is fairly similar, but we're going to do just a little bit more. Okay, so let's make this little note. Now let's see what happened when we reflected across the line, y equals negative x. Our 3 went to the y and it went negative. And the same for the 1. It went to the x term and went negative. So when you reflect across the line, y equals negative x, you switch the terms and make them negative. So this is going to be minus y comma minus x. And then our equations are x prime equals minus y and y prime equals minus x. Now this table is what you need to do all of your translations, all of your reflections. I'm sorry, not translations. So for cheat sheet notes, this would be a good thing to have in there. Okay, so let's use all this stuff to do a couple problems. Our first one, we're going to reflect a line in this case, but you can use the same technique for reflecting curves as well. So here's my line, 2x minus 3y equals 8, and we're going to reflect that across the y-axis. That's m sub y from the table right there. Okay? So our first step is to figure out what our equations are. So we're going to use this row on the table. X prime, the new x, is going to be minus the old x. So x prime equals x. And then notice how when we reflect across the y-axis, the y term stays the same. So we get y prime just equals y. So now what we do is we substitute that into the regular equation. So we get 2 times negative x minus 3y, because we're just putting in the same y for that, equals 8. Let's finish this up. This is minus 2x minus 3y equals 8. Now we have this standard for this type of an equation. The x term is always positive. That's what you need to do. So we're going to multiply this whole equation by negative 1, multiply it through, we get 2x plus 3y equals negative 8. And so that's the reflected line. This line has been started here and reflected across the y-axis, and we get that equation. Remember, we talked about this general form, how you can get slope just by looking at it. So let's look at the slope here. It's the negative of the x coefficient over the y. So that's going to be minus 2 over negative 3, which is 2/3. Okay, so now let's do this slope. M equals the negative of the x coefficient over the y coefficient, which is 2/3, which is just negative 2/3. So we reflected this line across the y-axis, and the slope changed from positive to negative. So we just did that to take a look. That makes sense. You've got some line, you've reflected it, so the slope should change. Okay, you're going to get some combinations in the exercise, so let's do one of those. Here's a point, 4 minus 1. The first thing we're going to do is we're going to reflect it across the line my equals negative x. So this is the one that switches the terms and changes their signs. So we're going to first reflect it across that line, and then we're going to translate it, which is a slide, for 3. Okay, so let's do the reflection first. We're just going to take that point, and I'm going to write it out in notation. And y equals minus x, put my arrow. And what's going to happen? Here's the y equals negative x. We just switch it. So the new x prime is the negative of the y, and the new y prime is the negative of the x. So we're going to switch the y and put it first. There's my new x, my x prime. And then this one's going to get put for y, and it's going to switch. So that's the reflection of 4, negative 1 across the line y equals negative x. Now, second step, we're going to slide this new point across that vector. So let's write that out. Minus 1, no, not minus 1. 1, negative 4 across 4, 3. So now we just do the addition. It's going to end up being 5, whoops, let's write it correctly, 5 comma negative 1. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.